So we look at one more interesting problem now, which will bring together a lot of concepts. I mean, it's a sequence of problems, but the first problem is find the number of arrangements of the letters of the word independence. And the choices are 1 6 6 3 2 0 0 2 0 0 0 0 0 0 1 3 8 6 0 0 and 1 3 8 0. So just see that the answer to this question is the first one, 1663200. We look at the solution, but I think you should be able to get it basically because these are just arrangements or permutations of letters of the word independence, and we covered questions related to that. So let us look at the solution. I just have objects which are the alphabets in independence, and what I have to do basically is to see that how many objects you have. So objects, you have 12 objects if you count all of them, and then you have to see how many of the objects are repeated. So going from the first one, just look at the repetitions of alphabets, and you will find that N is repeated 3 times, D is repeated 2 times, and E is repeated 4 times. Now you should see the pattern of what the arrangements or permutations are. So the number of arrangements will be equal to 12 factorial divided by how many different numbers. You have 3 different alphabets which are repeating, so you will have 3 factorial, 2 factorial and 4 factorial, right? So I'm not writing the formula again and again, but just you can see n factorial divided by p1, p2 and p3 factorial. So you'll just get familiar more and more, and you should be able to write it like this. So this is actually equal to 1663200. Okay, so we continue with another problem which is actually related to the previous problem in some ways. So you have how many arrangements of independence are there with 1 words that begin with P, words that begin with I and end in P. So there are 2 parts to this problem. So I'll give you the choices. 164 6400 138600. Second choice is 138600 12600 12600 24800 and 138600 16000. So this is the first choices for part 1 and the second choices for part 2. So the correct answer is the second one. Let us look at the solution now. For the first part, we have to find words that begin with P, and we have to use the objects in independence, right? So how many objects are there in independence? We found out from the last part, or you can look at it, it's 12 objects, and we only want words that have P in the first place. So only arrangements we require are with P in the first place, so P has to be fixed in the first place. So how many other objects are remaining if we already use up P for the first place? 11, right? So we have 11 objects that are remaining, and still we have in these 11 objects n repeated 3 times, d repeated 2 times, and e repeated 4 times. So if the total number of objects are 11 and you have n of 3 times, d in 2 times, and e in 4 times, how many arrangements are possible? You have 11 factorial divided by 3 factorial, 2 factorial, and 4 factorial, right? So it's very similar to what you did in the previous problem. And the answer is 138600. So the only key point here was to fix P in the first place, and then you are left with 11 objects, and you do the permutation formula. You apply the permutation formula on these 11 objects with these 3 alphabets repeated 3 times, 2 times, and 4 times. So this is very straightforward. If you look at the second part, that is words that begin with I and end with P, I think you should now be able to just do it even if you didn't do the first part. Just try to solve it now. What do? You again have independence, all objects in independence, and there are 12 objects. So we only want the words or arrangements with I in the first place and P in the last place or the 12th place, right? So how many objects are remaining in between? 10, right? Because out of 12 you use 2. So 10 objects are remaining. So we can arrange these 10 objects in any way we want. And even in these 10 objects we have n repeated 3 times, d repeated 2 times, and e repeated 4 times. So the arrangements now are 10 factorial, that is the total number of objects which you are arranging, divided by each of the objects that are repeated. So 3 factorial, 2 factorial, and 4 factorial. And this is equal to 12600. So this should have been pretty straightforward for you.